All right, so let's chat about the software development life cycle. So certainly developing on your own is so much easier than developing in a team. And so we would like to just look at real quick the history of how we have tackled large projects, right? Going from just being a chaotic, just iterate until until our client is happy, to where we are today. That AGILE seems to be the one that is being used throughout, and SCRUM in particular as an instance of one of these AGILE methodologies. And again, it's only to stress that it's all a work in progress. That these are just different methods we have been trying out for the last couple of decades, and perhaps it will evolve by the time you graduate, and perhaps you will come up with a better solution, a better methodology on how is it that we deal with large projects. Obviously, we're not talking about trivial things here. We're talking about where you might have multiple teams all having to collaborate amongst each other for a prolonged time. We mentioned some of the factors that each member of the team, different team folks might have at their disposals. The client, who needs this presumably, or has a perceived need for something. They have the money to spend, they have the time to spend, functionality, and they just want to make sure that their odds of success are better than just 30% or whatnot. And they approach a tech side folks who know how to build this, who can choose the technology, the technology stack, the methodology, the process they're going to be using, the folks who they're going to be hiring, and hopefully they'll come to a consensus on what is it that they're building. And so working in teams needs so much more communication. We're all flawed on understanding what it is that we need to build and what are the various priorities. So we use different tools to communicate, UML class diagrams, use cases, to requirements documents, specifications. It's to create a culture of folks that come and go, and with the idea to hopefully come out on the other end better off than we started. So in large teams, definitely we need more communication. We need to be able to hand off the piece of software, somebody who comes after us, somebody who might be replacing the team. There's a lot of turnover, folks come and go, and we need to onboard them. We need to perhaps give our product, our code to some other team. So we need to have some knowledge transfer. It has to be built in such a way that we can do that easily. Again, the notion that the software does not belong to us belongs to the team. Again, everything is moving. We should never fall complacent and feel that something is static. The requirements are changing. Again, folks come and go. People grow and eventually move on. So and also we fail to understand the importance of scale. Right, it's something that we might have prototyped that seems to work fine for a small subset of the problem. It turns out to be much harder when we are building it for production. That needs to be deployed in some environment, needs to be maintained, needs to be folks in the process that are going to maintaining this in production also need to be part of this. So the complexity just grows. When you were talking about a enterprise application, and also most of the time you're not going to get a chance to work on something brand new, pristine. Usually you'll be jumping in the middle of a ongoing story, right? And so you'll try to make sense of what has come before, why are things the way they are, and you might have very little say on how things might change, right? You might have, if you stick around for quite a while in the team, perhaps you will have a say on the direction that a team might go, but oftentimes you're in the middle of something that's already started. You're maintaining somebody else's source code, and that oftentimes is very, very challenging. And again, you are one of several folks in you're one cog in a huge machine. Right. So, but the intent here is to have good software, reduce the risks. A way for us to measure that we are indeed done. That we are making progress towards an agreed, measurable measure of done. Right. That we understand the preconditions of several use cases. And what are the expectations, what the outcomes are. All right, so some of the key activities that we find in any software development methodology is that, so first we're going to have to analyze this, right? Perhaps the architecture to design what is that we're going to be building, right? And then how is it that we're going to be building it, right? And typically those are two parts of this. The architecture usually defines what is it that we're building it, right? And the design might come up and say, well, how is it that we're building it? What are the concrete classes and relationships that we're going to be creating? Specification, coming up with agreeing on what is it that we're going to be building. Development is the actual act of writing source code and building all those various artifacts. At some point, we need to test it and validate it that indeed it meets the original specifications that were actually done. Once it gets deployed, that's only half the challenge, right? After it gets deployed, there comes the software goes into a completely different life cycle, right? It needs to be maintained. Requirements are going to change over time. But with something that is in production, something that is already running, something that somebody is already using. So it has its own challenges. Now, so these are the key elements in any software development life cycle, right? Where Waterfall says it's a one shot. Right, you do this once. You start from the beginning, and you go through all these steps and all the way to the end. Right? I think we've come to an agreement that perhaps that's not the best way. Now, today, agile methods instead, what they do is that they apply this over and over, right? In a very tight loop, right? That every 2 weeks they go through this entire exercise as opposed to just once through. If you just do it once, typically you'll be tackling something that's very, very huge, and that if you fail, it's you just got one shot to get this right, as opposed to iterating multiple times and doing small things and correcting as you go. So each one of these of the methodologies and processes that we're going to look at have all these aspects, right? But it's just that in the order that they implement them. And how many times do they do it and whatnot is how they differ from one another, right? All of them have these key aspects that we've identified as atomic activities. Right? We always as human beings we like to overpromise, but we oftentimes we underperform, right? So the various process models. So yes. More than half a century ago, this is what it looked like. It was very ad hoc, kind of like everybody did everything. There was no distinction on who should do what or any specialization. Today, in systems that have grown in complexity, we do have folks that specialize in their skills for various different concerns in the applications. Applications today deal with front end and storage and middle tier. We've matured as an industry and identified these key aspects of the application, right? And each one, we might have several sub-industries where you could do an entire career on just one aspect of the application. Back then, everybody did everything. It was a very tight loop of modifying. You give a first approximation and then you modify until the client said, I'm done, I'm happy, that's fine. It was very ad hoc. There was no real process that we were following. There was, again, no division of concerns. That storing the skills of knowing how to store data are different skills that you need than presenting data to the user. They're completely two different types of skills, right, and different concerns. So back then there was no deal separation of concerns, and how to deal with the difference between dealing with something small and then making it much complex. So waterfall was one of the earlier methodologies that were proposed early on to deal with this, with the complexity of dealing with large applications, and basically it applied those 5-6 steps in sequence, right? So there would be one large. Somebody is calling. There would be one large amount of time that we would do a feasibility study, right? Once we completed and arrived to the conclusion that yes, we can actually build this, we would go on for another couple of months and gather all the requirements. We would meet with everybody, and until we didn't know exactly what we were building, we didn't get started, right? We wouldn't design, we wouldn't select an architecture, we wouldn't code anything, right? And until we know exactly, even though everybody didn't actually understand the problem there very clearly, we would agree on something that we didn't know too much of, right? It's kind of going somewhere and not having a map, but deciding to go anyway. Architecture would follow that. Then obviously the development, but we wouldn't start one without completing the previous one. There was no backtracking, going back to say, hey, can we back up and see if this makes any sense? Can we meet with the client and see if there's any input or feedback from them? And there was no way for us to show anything yet, right? So this was, today it's considered to be fairly monolithic, since there's no backtracking or including the client as part of this part of the discussion. And today mostly we've taken the same ideas, right, of the same 6 steps, but say instead what we've done is said, well, let's put this in a loop, right, in a very tight loop, and be able to iterate over this. But we've learned a lot from this. We still use a lot of the same ideas of documentation. We create use case analysis. We create where we identify certain actors that are going to be using this, that are impacted by this, or trying to have a particular goal that they want to achieve with the system, and we describe them in a fair amount of detail. How is it that the user is going to achieve, or an actor is going to achieve that goal? Typically, we come up with a precondition saying, assuming that the system is in this particular state, they've logged in, that they have an account, that they might have something already in the shopping cart, they might have a payment history. Based on those preconditions, if they follow these scenarios, these steps, to either return something online or add something to the cart or whatever they want, or they want to review an order. We would have a use case for each one of the different goals that the user might have, and specific steps that they might follow, and the expectation of what the post conditions would be. Then we would go on for a couple months and decide the planning, what we would do first, assuming a mythical man month, right? How long would somebody be able to somebody code based on how much time you would give them, and we would plan out what we would do first, and then after that we would do next, and so on and so forth. So we had this huge Gantt chart that would spread out the various activities that we were going to be doing. And then we would go on and start modeling this, clearing class diagrams, sequence diagrams, all the various documentations that we would need, model it, activity diagrams, packages, deployment packages, and so on and so forth, and ERDs and the schemas that would go along with that, and we would part of that analysis and getting ready for the construction phase, the implementation. We would go off and implement it with some confidence that ideally we were going to be building what we were asked to build. And we would deploy it, test it, and then we would get the feedback from the users. But oftentimes it was too late. Any changes in the market, any changes of mind by the client, none of that played into the process. And once it was deployed, it was kind of too late for the client to make any changes. This is kind of trying to capture that they're going on an expedition for jungle where they've never been. So how are you going to find your way there? We already spent 6 months drawing maps to a place that have never been there. So it's kind of like a chicken and egg, right? So how can you draw anything if you haven't been there? How are you going to work there if you don't have a map? So what newer processes do is says, okay, well, let's do that, but instead of tackling the entire unknown, uncharted, let's do it. Instead of deciding that we're going to go to a very a hard place to get, let's have more modest ambitions, right? And once we discover new things and we maybe learn how to live off the land, we can then make a better decision once we've gotten started. So one of some of the issues with the waterfall model is that the development process itself is rarely sequential, right? I would say that our process is still very artistic. It's still tied to many preferences, personal preferences. Even though we're trying to remove those things from software engineering and create best practices and several templates on how to design patterns and how to do things, how to not do things. We're trying to create predictability into the process. It's still, it's a very ongoing process, right? We still have preferences on how do we write things. So the projects are rarely sequential. Oftentimes it's too early to know what the requirements are until I see something, right? Again, the chicken and egg. Oftentimes we don't consider how projects evolve over time, and the customer just has to sit there waiting for this whole thing to come back and then not be happy about it. And because it's inflexible, any deviations, any early decisions are going to have huge impacts later on, right? Because they're very big decisions early on are going to have big impacts later on. So that's why we in the Agile we try to make very small decisions early on, right? So that if we make a mistake, they have smaller impacts, in these small iterations. So it is in the requirements in the design phase that projects in general are most at risk at failing, right? If we don't get this right, the requirements in design phase, right? We're gonna the cost of fixing these things is prolonged over time. The more we wait until fixing any of these requirements. So the more we wait in time to fix the requirements early on, right? Just the cost gets larger and larger because we've committed to doing something. And the more you commit, and the farther you go out, just the number of artifacts that we need to change just grows exponentially. So the cost gets larger. So some of the ideas at fixing this initial methodology says, well, what if we, instead of doing a one-shot deal, right? Why don't we break it up into smaller increments where we first in the first increment perhaps we come up with the core, the minimal viable product, right? What's the core functionality that the product needs, right? And we forget about some of the nice things to have. We just on the first increment we deal only with the core, and then in additional increments later on. Once we deploy it and folks get a chance to play around with it and break it, we can then deal with some of the problems in the first iteration then it could be part of stories and features or bugs that get fed into additional increments. So this is kind of the beginning, right, of where we are today, right? And, coming up, realizing that one-shot deals were very risky. Let's break it up into smaller ones. So the incremental model is to have multiple increments that each sequence just gives small increments in the viable product that gets deployed. In the first increment we do the core product, right, and then we wait for features in later increments. It becomes more flexible. We can allocate folks to move around easier, and we typically prototype, especially those things that are the riskiest, the ones that we understand the least. Right? If we've done certain things in previous projects, perhaps we don't need to prototype. But typically, if it's a new technology that we're not familiar with, if it's a new technology stack, we're using a brand new service, ideally we prototype it, right? To gain some understanding and lower the risks of using this a later point. So in the prototyping phase, we measure some of that early on. There's a couple of different types of prototyping. We might consider to do prototyping for a particular technology stack, right? Maybe in the UI, right? Maybe we're going to all be using Angular, or we're going to be using React, but nobody in the team knows React. So that's pretty risky, right there. If the team doesn't know, so we might have multiple sessions of implementing. Maybe we know some other technology, JWT or AWT or some other .NET. Maybe we're a Windows shop, but we're trying to move on to this thing called React. So we might prototype certain things, right, to try to understand and map things that we might know onto newer to minimize the risk. Or we might do a vertical prototype where we might not understand how the interaction in user interaction might eventually make itself into a database or stored or retrieval, right? And it might have to go through multiple layers of technology, right? The UI, connecting to the service, connecting to the data layer, connecting to a database, and maybe we don't understand that very well, right? So we might prototype the whole thing enough for us to feel comfortable that we understand the entire stack. So prototyping it's a very important aspect of early on, right? Managing some of those risks when we're going to tackle start in one of these iterations, right? Every time that we get starting on these iterations. Okay. So here's prototyping. So there's prototyping at different layers, either at the UI layer or the bottom layer. Maybe we've been using. We're very familiar with SQL databases, but now all of a sudden, NoSQL seems to be all the rave, right? So we might not feel comfortable with implementing those things. So typically we would, prototype those things. We know how to implement one-to-many, many-to-many, mappings and whatnot, and foreign keys and primary keys in MySQL. But all that goes away when we start using NoSQL and Elasticsearch and all these new ways of data storage. So we might create, a prototype in the bottom layer for creating the data layer, right? The DAO. How will we implement that? What are what things map things that we might understand, and what are the best practices for that particular implementation? Same thing for the top layer. We would prototype these things. Oftentimes we would prototype using very very simple throwaway user interface implementations that we can very quickly give to the user, typically maybe just paper or PowerPoint or maybe Excel or something that somebody can click on and interact with this and quickly give us some feedback on whether this user interface works for them. Or again, we would do a vertical prototype that would go across the multiple technology stacks for us to understand how things flow across multiple layers. Right. So horizontal prototyping is a very common example is user interface. And verticals go across multiple layers. One of the things that we need to resist is that oftentimes, we might demo some of these prototypes to some of the stakeholders. It's maybe some VP or somebody who might not be technology oriented, and they look at the prototype and they say, "Oh, we're done. Right? It looks like it's working, right?" And so it's very hard to manage that expectation. And then how did you get so quickly at implementing a small version of the whole product? Why am I going to have to be here for the next couple months or years, right? For implementing it correctly, yes. So that discussion is very, very sensitive. It's very hard to manage, right? Also, it's very common in immature teams to make this first approximation of the product that was meant for a prototype, right? Just for us understanding something, and then slowly growing it. Okay, just extending on it. Says, oh well, why don't we just add this other thing, and let's you're back to where we were, in the 1950s, right? Where you're just iterating over something that was meant for a throwaway, right? Typically, prototypes you would just do it for understanding something. You throw it away, right? And then you start off doing it correctly. All right. So be careful not to resist the stress, the pressure to convert the prototype and evolve it slowly into the product. Okay. Oftentimes for prototypes, you've made a lot of shortcuts, right? You've done a lot of assumptions, right? Just to quickly show something, an example, right? So oftentimes you might have done something that you would normally do in production code, right? So again, just throw away the prototype and start designing again. So other ideas that came about at how is it that we iterate, right? And people were envisioning the process as being some kind of spiral that would go through several of these of multiple times through communication, planning, modeling, construction, test, deployment. Communication, planning, modeling, construction, test. So if people envision this in their heads, this kind of spiral where where in the center you would focus on the core functionality, and then slowly would add to this core functionality some of the other features. Right? Always again maintaining good practices and good and some of the standard ways of implementing things. Right? It was the first. It was the beginning of us understanding that software is an evolving thing. Right? It's not monolithic. It's not that we're going to know exactly what we're going to build, and at the end we're going to have exactly what we wanted. Instead, this was the beginning of a realization that just software is evolutionary. It evolves. It's not revolutionary. It's evolutionary, and that we might set clear milestones for each one of those spiral iterations, and it would just go on forever. It would just spiral, can continue forever. There is no end to this, right? You can always improve on what you have, and it kind of it lends itself better to the iterative nature of the development environment, of the development process. So now instead of having just one circle, you might have multiple iterations of this, and then you get an increment of these things, right? So again, this was the beginning of this notion of iterative processes and the precursor of what we refer to today as the agile, right? That these iterations became smaller and smaller and smaller. Today, the more common thing is to do it perhaps a 2-week sprints or 1-week sprints. But some of them, if you're in the extreme programming, they take this to the extreme, where you might have an iteration in one single day, right? You might have multiple iterations in one single day, right? Where you can deploy things multiple times a day. Yes.
So one thing that I'm still a little fuzzy on is, even though we have a really tight development loop in something like this, at the very beginning you still have to define what is the priority of things, and so you still have this issue of
that's still the hardest. Yep.
Defining a lot of stuff that's really critical and important up front, and then still.
Yeah. So right. So you first you try to do the things that you do understand, and realizing that there will be a whole bunch of things that you don't understand, and you might put very broad policies or very broad goals that you want to achieve, but everybody understanding that we don't understand this enough. That as we tackle the things that we do know, some of the core functionality, we will probably be at a better place when we do discuss this later on. And also when we have that discussion, it might open up an entire can of worms, right? And we all agree that we don't understand it enough, as opposed to making decisions in the waterfall that you're asking me to make a decision on something I don't understand, but nevertheless I need a signature from you, right? As opposed to here, all realizing that we don't know enough, right? And that we'll tackle that at a later time. We might do prototyping, right? We might do prototyping enough to feel confident that it won't be a showstopper, okay? So that would be part of the feasibility. So is this even feasible? Can we even do that, right? But we won't go further actually implement it, right? But we'll do enough to feel confident that it won't be a showstopper. Right? But we won't spend more time than that. We'll leave it that in later iterations. So in the inception phase, again, as we're iterating over this, there's lots and lots of communication and planning. And at the end of this, we do some use cases. And some of the things that we're moving away is that in the previous waterfall models, they were very, very heavy on documenting everything, right? Developers felt that how am I going to implement this if it's not documented? And it sounds like it makes sense, right? That I can't start until it's documented, but oftentimes we didn't understand enough to document it. So it is when I'm going to develop it is currently when we decide to actually document it, right? To come up with the actual use cases and plan around what we're going to be doing. And again, these are going to be smaller things that are going to have small impacts, incremental impacts, as opposed and small risk. If I get it wrong, it's okay, right? It was only 2 weeks that we lost, right? So communication, planning, use cases, architecture is very, very broad, just an outline. Perhaps we've prototyped enough to understand the architecture, but not enough to actually do any hard documentation. We expand on the use cases. Perhaps we actually meet with some of these folks and do a lot of the detail specification of how you actually achieve the use case. We extend more on the architectural and start designing the model. We start the build phase, right? As we build, oftentimes we know more about the model. We might have realized that as we build it, we might need more tables, more classes, and that feeds back into the documentation. We create unit tests, and then we define a criteria by which the owner is going to accept this, right? What is the end goal that the user is going to say, yes, I'm going to accept that, and that's the acceptance test by which we define our job as being complete. Based on those results, feedback from the users, and whatever differential there is between what we were going to do and we actually did, that differential becomes stories for the next iteration, right? So those defects feed into the next iteration. It gets deployed. Problems are monitored. Typically, we will deploy knowing certain issues, and we'll keep track of those and see how they behave in real time when it gets deployed. Right, the feedback feeds into the next iteration. So there were several attempts at implementing this idea. Some of the processes were a little more had many more rules than others. Agile tends to be the lighter one that has they're very broad policies, but it's up to the team to actually decide how to implement them. And whereas the unified model, kind of had a little more rigorous. The RUP model had a little more rigorous rules on how to implement this idea of the iterative process. But they all follow the same idea, right? Just the iterative process. Yes.
So in the waterfall model, every phase of the waterfall process could effectively be a different team within the organization.
I'm sorry. Can you say again?
So in the waterfall process, every phase of the life cycle sometimes was actually different teams.
Oh, sure.
In this unified process, is there still that team breakdown?
Yes. The more we went away from the waterfall model, it turned out to be much smaller teams that ideally they were had a very low coupling, right? Some very low dependencies amongst them, and the idea would be that most of the team members were very senior. They've gone through this several times. They were tackling very specific part of the product, as opposed to in the waterfall model. Typically, there were large, huge, humongous teams all working together. Perhaps not all of them as senior. They need to be as senior as today. Typically in a Scrum and an Agile environment, typically you want fairly senior folks that have gone through this, are committed to working together, co-located next to each other, seeing what you're doing and you're looking at what I'm doing. So it's a completely different culture. But yeah, so today typically in the Agile you have very small targeted teams. In those, it used to be in the waterfall you had huge teams. Yeah. So the unified model it was trying to capture some of the best of both worlds, right? Definitely the waterfall had its ideas. It set the stage for what are the tasks that we need to do in any of these, right? It emphasizes the architecture and the design, and actually integrates very well with the UML models that we're going to be looking a little later, where there's documentation for each one of the artifacts that the unified process generates at each one of these steps. Right? Each one of these steps generates a type of documentation for which we have a type of diagram in the UML model. So this is a very common way that we refer to, in contrast, the waterfall model as opposed to the newer, more modern approaches, where we have this big ship that is hard to turn, has a huge amount of inertia, right? And any modification just takes a long time to turn. And today we say that we're nimble, we're lean and mean, and can turn on a dime, right? So that's the intent that we're looking for. So Agile, it's kind of the latest iteration on this idea of the iterative process that tries to focus on some aspects more than others. Instead of being adverse to change, right? Where in the waterfall, any change was very expensive, as opposed to we are welcoming to change, right? We're designed from the bottom up to welcome change. Again, if our iterations are small, changes are fairly inexpensive, and instead of getting into a discussion or an argument with our clients that hey, that's not in the contract, right? That we say no, that's not it. Show me where that's written, right? That this disagreement of what we said we would do, instead of getting in an argument, say, okay, well let's look at it. Let's collaborate. See if we need more time to do that. Can we negotiate what in a new feature or a change in feature? Can we change the time that we're going to deliver? Can we move things around? We'll work with you. Okay. There's less focus on documentation, right? Whereas in the waterfall models, it was heavy on documentation. Everything had to have a class diagram, a wireframe. Everything had to be perfect before we built it. Here, we'll just sketch it, and and part of our discussion will come up with an approximation of what we're building. Anyway, it's going to change. Any documentation that we write will be stale anyway, right? And oftentimes we say that the documentation is the source code. The source code is the documentation. What's built is the documentation, right? How is it? Look at the source code. That's the documentation. And there are two schools here. Those that want source code that is documented, right, with all sorts of comments and whatnot in your source code. And the other school says, well, if you need documentation, it's because your source code is not self-explanatory. Right? You should write code that is self-explanatory. It's so simple to follow that you don't need documentation. So there's two schools of thought there, that the source code should be simple enough that you don't need documentation. The source is the documentation. Also stresses the the individual and activities over whatever process we're dealing with. And the whole idea is that when we see something, say something early on. The earlier you see something that doesn't jive, that is inconsistent or that is contradictory, right? Or somebody in the chain of the users and the stakeholders, whenever they see a change, just let everybody know real quick. See if we can adapt and initiate an action as promptly as possible. Can we come up immediately with an alternative plan? Again, assuming that we're not looking for a big bang at the end. We should be able to deliver at any time, right? We should this week, next week, whenever, right? We should have a core product and then just iterate and add an additional value each week or every other week, assuming that we should be able to call it done at any point in time. There's no necessary to have a big bang solution at the end. So there's several different versions that follow this policy or follow this philosophy with varying degrees of structuredness, right? XP is we would say it's the less structured, right? It's very open-ended, whereas you might have the RUP has more, quite a bit more prescriptions. Okay, so we'll talk about these in general as we go. So agile. So basically it's just what it's what we've seen so far, the waterfall, but just a loop, to just loop around, right, and make it a tight loop. So these it's just a kind of evolution, right? We have a waterfall, and then the iterative is just mini waterfalls one after another, and agile is just making it tighter and tighter and tighter, right? And you have maybe XP, make it the tighter as possible, right? If you have just 1 day iteration. Now in both these under both philosophies, you might have different needs for or the types of problems that you're trying to tackle, and things that work well. Typically in the agile, we're looking for smaller development teams, right? That have worked well together for quite a while. They enjoy coming to the office and actually sitting next to each other on a desk. Maybe not necessarily on their own cubicle or their own offices. Maybe they have a war room where everybody meets, right? And they can just sit and collaborate with one another. They thrive on chaos as opposed to they demand order. They're okay with requirements changing. They're very senior developers, and they're tackling small things, right, that are not critical, right? But in the increments, right, in the totality, it is critical, but not each individual task that they tackle. Right. So the idea was that the reason we went this road is that requirements were very hard to predict. Right. Folks were being asked to make decisions on things they didn't understand, and that the design phase oftentimes, it's too early to design it until you actually start implementing it. And we came to the realization that it's a very interleaved activity that we want to design as we are implementing. And a lot of these things, analysis, are not predictable. Right. So extreme programming is just an evolution in this, and that takes into extreme all these ideas, right? Of tightly coupling the client, of testing and iterating code and changing the code. With lots and lots of refactoring, where they write tests as as a fundamental step in their development cycle. Right, they write the tests first, and for them, in extreme programming, the test is the definition of your understanding of a requirement. Right, it's a representation of a requirement. Right? If I don't understand a requirement, I can't write a test for it. Right? If I understand the requirement, then I can write a test for it. Right? So they go hand in hand. Is part of me trying to understand what I'm trying to build, of what you're asking me to build. Right? So if I understand what you're asking me, I should be able to write a very specific, very explicit test that will tell me, yes, you have achieved your requirement. So we'll a lot of these stories we'll in the planning phase we'll write lots of stories, and perhaps in forms of stickies. And each of these stickies, we'll do a very preliminary design. Again, keeping it as simple as possible, not trying to foresee what we're going to be doing, how this is going to evolve over time. And those kinds of things we can't predict. I mean, and it's very common that you go into any system today, and you realize how over-designed things are, over-architected, over-engineered things are. Right? It's very common that you start going through a data model or set of tables in the database, and you find table after table that has just empty data, just nothing in it. Right? Or you'll see that tables have tons and tons of these fields, and which most of them are null, right? That maybe 3 or 4 columns have data, and you'll find 90% of the columns are empty, right? That's a clear indication that somebody over-designed this, right? They were trying to predict, right, how eventually somebody was going to use this, right? And they weren't keeping it, they weren't keeping it simple, right? They were trying to try to see in the future how somebody was going to use this, and they went away from the core functionality, right? They instead of just focusing on the core functionality, they tried to say, okay, well, what if, trying to address many edge cases, right? That impinge on the original design, right? So extreme programming says, no, screw that. We're not going to do that. We're just going to keep it as trivial as possible. Let's focus on the core functionality, and each one of these stories becomes unit tests, right? That they are an explicit implementation of what I understand the requirement to be, and they see it as a means to challenge the requirement. Is the requirement even needed, right? Or is it complete, right? Is it consistent? Is it do we even need that requirement, right? If I can't write a test for it, right, then certainly it's not complete. Certainly it's missing something. Maybe I'm not interpreting it right. Right. So it forces folks to go back to the requirements phase and say, okay, well, let me ask the client again, right? If we can be more complete on this, right? So don't take requirements as something fixed, right? If you cannot implement a test for it, then certainly it's not a very good requirement. And then we iterate, refactoring our code to write it to pass the test. Right? So we write the test. The test hopefully is representing some requirement. And the code, any code I write, is to pass the test. If I pass the test, it means that I have succeeded at implementing a particular requirement. Okay. It's heavily based also on very tight collaboration with your team fellows. So typically, the company will typically stress the need to come into the office, right, and actually sit next to your fellow developer, right? It's hard to do this when you're not co-located, right? When you're remote. So a lot of some of the companies that push extreme programming and Scrum and all these newer ones, they stress the need to create very tight couple folks that work well together. Right. So any defects that they might find, right, measures the level of progress and any missing functionality that then make it into the next iteration. So some might say that it's very, very similar to where we were, 50, 60 years ago, right? That isn't this more or less the kind of ad hoc way that we used to do this way back, in the 50s? In some sense, it is, but having matured this, we're kind of coming back. This is very common in our industry where we, just go one, the pendulum swings one way, and then we overcompensate and go the other way. But we're coming back to this code and fix in a much more mature, having understood the problems and the challenges, right? So now we understand about complexity. We understand about division of labor. How do we break it up into multiple teams? How do we integrate these things? But back then it was really ad hoc. We didn't know what we were doing. Scrum is one of many. Is one of more used methodologies or instances of Agile, instances of Agile that implements the iterative and incremental managing software process. It focuses on having small teams that to maximize making sure that we communicate, minimize any overhead, and we welcome adaptability, and we have frequent software increments. Typically, you might have multiple teams that break out that have low dependency amongst each other, either with a well-defined interface or set of APIs that interact with one another, but within a particular set of requirements, the team is partitioning into this low coupling partition. Constant testing, documentation, and again, as I mentioned earlier, the capability of just calling it done at any point in the product. Typically, you have 1 or 2 weeks or even 3 week sprints where folks decide early on what is it they're going to be working on. Usually, the product owner and the business analyst and the client meet at the beginning of the sprint. They decide the relative priority of certain tasks. Typically, there's a backlog, which is one big bucket of things that need to be done, right? That we might not know exactly how, which one should go first. And at each beginning of a sprint, we decide, well, out of that bucket, right? What should we call it grooming? We start grooming through that bucket list, right? And decide what things we're going to be tackling the next sprint. We might have kind of an overarching plan of what we want to tackle over the next several sprints, right? And based on that large epic set of goals, right? We might break it up into multiple sprints, and with an end goal of at the end of the epic. So we decide to put things into the sprint. We load everyone. We ask each one of the developers, how complex do you think this is? We take out planning poker cards that are typically numbered, in kind of like a Fibonacci number, and everybody gets to vote on how do you think this how long or how complex do you think that this task is. So it's kind of giving everybody a chance to hang themselves with their own rope and says, what do you think this is worth, right? How complex do you think, from a scale from 1 to 100, in a Fibonacci scale, how hard do you think it is? Is it a 1? Is it a 2? Is it a 3? Is it a 5, an 8, a 10? What is it? And everybody plays poker, and some folks will, most developers will agree on how complex something is. Some folks will be very, very low, thinks that it's trivial. Some folks will say it's extremely hard, and everybody will kind of speak their mind. Why do you think it's a 1? Why do you think it's a 10? Why do you think it's a 20? Right? And we come to a consensus at planning and saying how complex do you think sorting this list is, right? If you click on this icon, sorting it and re-rendering. And then everybody gives story points to their own task. We go off, everybody gets loaded on so many points per sprint, maybe 20, 30 points per sprint. And then we go off for the sprint, we go through a design phase, right? We do some prototyping perhaps, we meet with the client, giving them some alternatives. How about we do it this way, that other way, and we go off and implement it for a couple of days, and we move the story along. Typically, project owners and the VPs or whoever the manager is, they want to see these stories being moved across, from the beginning to the end of the sprint. Being moved. They want to see a smooth flow of these stories coming in through the beginning of the sprint and out the other way, right? At the end of the sprint, we demo it, right, to the end users. We give it to it has gone through QA, through code review, through user acceptance. User has looked at it, demoed it. We demo it to them. They accept it. At the end, we have a kind of like a retrospective where everybody gets to speak their mind and then see how the process worked. And some folks will have complaints about the process. He says, the UI guy, he wasn't available. He was being shared by some other team. The database DBA administrator was not available. He couldn't set up the schema for me, and all these kinds of complaints, right? Ideally, you would have tackled that early on in the sprint, right? You would have spoke up early on, yes, and we might have maybe put that story to bed, right? And maybe give you another story, right? So ideally, we wouldn't be at the end complaining about something we didn't say anything early on, right? Ideally, we want to speak as early as possible so that the manager has a chance for you to move things along. Typically, every day you get a chance to speak up, right? Every day we have a 15-minute stand-up where everybody stands up. Ideally, because nobody really likes meetings, so we all stand up. So everybody's uncomfortable. Everyone wants to go back to the scene, so that folks don't ramble on, right? These scrums, these 15 minutes daily meetings, are for folks to tell me what was I supposed to do, what actually got done, where am I stuck, right? If I need somebody's help, and if I'm stuck, then it goes in somebody else's bucket, right, to unstuck me, and then I'll work on something else, right? So that the manager gets a chance to reassign or move resources around. So ideally, by the end of the process, right, you won't have a complaint because ideally we have to address some of those complaints. Nevertheless, we might have complaints about the overall process, right? They say, maybe we think we need more design. Maybe I'd like to know the overall goal of the project. Maybe I've been focusing too much on my own little world, and I'd like to know more about those things. So the manager might decide to have these kinds of discussions. So nevertheless, at the end, depending on what we said we would do, on the number of points that the team decided to go on, and then at the end, we see how many points we actually got done. Right, that gives us a score. That gives us a velocity. It says, "Ooh, you can do so many points per sprint," right? And so that kind of gives us over time, right? It lets us know more or less on average, how many points we can actually tackle over time, right? And so it kind of gives us a look ahead and said, well, if we were able to to measure or calculate the overall complexity of each one of these tasks, that gives us a kind of like a projection on how when we will be done, or where will I be 6 months from now, right? A month from now, or it gives me, if these are so many points, how long will it take me to accomplish all these points? And notice that the points is very, very subjective, right? It's how you think something is going to go, right? And it's you try kind of hang yourself with your own rope. So oftentimes a good manager will insist that that you're not over optimistic, right? Don't think that you're going to get that done in a day or 2 or 3 days, right? Very over pessimistic managers will double whatever that you tell them, right? If you say 2 points, it'll be 4, right? If it's whatever, they'll double it. So ideally, right, as the team coalesces, they'll get a better sense at what are they actually capable of, and their predictions will be more and more on the dot, right? So the accuracy of that velocity will grow over time. Yes, right. It'll be much more predictable as you go. So you have a backlog, kind of a bucket of everything, of all everything that needs to be done. The sprints, I've worked on teams with 1 week sprints and 3 week sprints. I think the ideal is kind of like 2 week sprints. I think 30 days is way too long. 1 week is way too short. With very, very short sprints, you end up with a lot of overhead. You're getting started. You're like in the design phase. You're starting to implement, and like it's over already. You didn't have a chance to. So there's like a lot of overhead on the design phase and the architecture and the demoing. You're kind of like the demo's coming next week, and the demo's coming next week. So you're like on top of demo right after that. So that's kind of tough. So I think 2 weeks is pretty good. 2, 3 weeks. I think 30 days is way too long. Scrums are 15 minutes and demos at the end to demo and give feedback from the users, from the end users. Some other ideas, feature-driven development. This kind of grew out of the object-oriented software engineer when it was new, when object orientation was a new thing. It says, well, can we break it up by class? Can we break it up by the hierarchy, right? And that kind of gave you an idea of the complexity of the piece of software that you were building. You have these classes and these inheritances and overriding, overloading, all these functions. Can we decide to plan based on those functions, based on those classes, based on that hierarchies? And typically each one of these classes presumably needs to be stored in a database. So along with all those object-oriented design that goes along with it, you're going to have to create all these CRUD operations: create, read, update, deletes, that goes along with that data layer. Yes. So it was so these features, we were used as a basis for deciding what was going to be the functionality that was going to be delivered based on a organized business related to the complexity and the class diagrams that you might come up with. They were also decided on 2 week pseudo sprints and design, code, inspect. Some of the same ideas that today we kind of take for granted, where we would create these kinds of stories. Well, today we would call them use cases. Like examples: add product or shopping cart, display, take us into a product, right? So these are feature groups that would be organized in a hierarchy. Very, very similar to what we have today. Develop the overall model, build it, plan, design, feature. So all of these kind of fed each other with a lot of the same ideas. So models, as we mentioned earlier, modeling is just a means of trying to represent something, trying to understand it. I think I'm supposed to skip over these. Right. So in the sprints, right, we can tackle. Typically, we can either tackle a user interface all across, or we can tackle perhaps horizontally across the different layers. More and more you see today, managers are looking for full stack engineers, folks that feel comfortable at any level of the layer, right? In big enterprise applications, it was very common. It's still very common that you find developers that only feel comfortable working at the top layer or only feel comfortable working at the bottom layer. More and more, we're looking for folks that feel comfortable on either end, and there's a lot of effort for companies to retrain their workforce, right? Folks that have been DBAs for forever, right, or been stuck in the service layer forever. Train them in Agile and in Angular and React, and giving them small things to do, and over time to train them that they feel comfortable across all the entire layer. Test-driven design, another idea, right, where we specify the tests early on. It's a fundamental part of the design phase, and with the idea that it is a chance that when you're designing the test, is a chance for the developer to challenge the design, or challenge a requirement that make sure that if I only understand the requirement, if I can actually write a test for it, and that there is no inconsistent understanding of what's done. If it passes the test, and the test represents the requirement, then we're done. Right? That is the perfect definition of being done. Now, giving a family of processes and different methodologies that we can choose, XP or Agile, Scrum, and or even Waterfall. Waterfall is still a valid way of developing software. If it's something small, something that everybody understands, something that's predictable, that's not going to change, perhaps Waterfall is indeed a better approach. Which one do you choose? And it always depends on again how things are changing. If you want to find errors early on while you're developing, or once it's deployed, and when does the client expect to see something? Right? So is it right away? Is it something they're going to give us and then walk away and then not be part of the conversation? So depending on those, we might choose different types of processes. Some of the views back on what we could expect on the success or failure of projects. Some of the pessimistic views is that we're going to kind of stay the same as in the 1990s, where you have only a very small subset of the projects really succeeding, 20 to 30%. Most of them needing large amounts of rework. Again, another 20, 30% being complete failure. Ideally, this is where we're going towards, right? Where in lean, iterative, and agile, you have most of them are fairly successful, and only a smaller percentage of them are either complete failures or need a large amounts of rework. So this is what we hope we will be. Not quite there yet.